Hello and welcome to the video series where I explain some basic computer science concepts and how they apply to real-world situations. Today, I'm talking about the Cartesian Product Trap, or more precisely, Data Redundancy issue. Now, I'm not sure I'm pronouncing that correctly. Is it Cartesian? Cartesian? I don't know, I'm gonna stick with Cartesian. This issue is the often forgotten sibling of the N+1 problem, which is very well explained in many videos here. In short, the N+1 problem is about too many trips to the database, which slows your application. The solution to the N+1 problem is to use a join in your SQL statement. However, if you rely on this too much, you will hit the data redundancy problem, or as it's often known in the developer circles, the Cartesian product issue. In this scenario, the performance of your application is not killed by latency or too many small calls to the database, but by volume, one trip that is too heavy. So today, we look at why one big query can be as dangerous as many small ones. I love to start with the definition, so let's see what a Cartesian product really is. Basically, when you combine every row from one table with every row from another table using a cross-join, you get the Cartesian product. In reality, though, you may not use a cross-join in your SQL query, but perhaps a left join. Strictly speaking, if you use a left join, you don't have a Cartesian product anymore, but a mismatch granularity or data redundancy problem. This simply means that your datasets have different levels of detail, and your solution to the N+1 problem may result in a massive data transfer between the database and the application. This will inevitably slow down your performance. A real-life example of this issue can be a blog post that has 5,000 characters and maybe 20 comments, and these comments are stored in a separate table. When you do something like select blogs.content, comments.body from blogs left join comments on blogs ID equals comments blog ID, you are downloading 500 character post 20 times, once for every comment. Yes, you have solved the N+1 issue, but now you have to wait for the database to serve all that redundant data, and your network may not handle it fast enough. Furthermore, after getting the data, it is often used for hydration, that is, converting rows into objects. So your O(n times m) problem becomes O(n square problem, and we saw in the previous video why we should avoid that. Okay, let's do some coding. I have already prepared this PHP file that contains a few SQL statements, so you don't have to watch me type them. I will not use a framework, I will just use pure PHP with its own PDO database interface. So first thing we do is we create a table of posts. We just have an ID and content, and also we create a table of comments which is connected to the posts via this post ID, and each comment simply has a body. So to begin with, let's create a post which is quite large, so let's do something like heavy content str repeat, and repeat something like dummy data, and let's repeat it 2,000 times, and then we will insert this heavy content into our posts table. Next thing we will do is add 1,000 comments as we have in this comment here. So to do that, I will use this statement that's already written, and then I will loop 1,000 times. So for I equals 0 to I less than 1,000 times, I plus plus. And what do we do inside the loop? We go stmt execute, and we will just add comments basically. Comment I. The next step would be to create a class called post model that we will hydrate once we get the data from the database. This is something that a framework would do, so we will try to kind of emulate that. So let's make a class post model, and this class will just have a public function construct, and it will not do anything, just accept public content and public comment. So we will hydrate this with the data from the database. So now we need to get the data and do the hydration process, and let's see how long that takes. So let's start our time counting with start equals micro time, and then we already have this results query, which basically selects everything from the posts and everything from the comments, and using a left join, and we connect the two tables via this ID, which is the post ID. So once we have the data, let's create an objects array, which will be a simply empty array to begin with, and then we loop through the data and create objects and save them into this objects array. So while row equals res fetch, we get an associative arrays from the database, and we simply say objects is equal new post model, and we send simply row content and row body. Oops. As the comment. So we have a large number of objects here, and let's see how long it took to get the data from the database and hydrate our model. Time join equals micro time true minus our start time, and let's echo that. I don't know, join method took number format time join 4 seconds, and let's run this, see how many seconds that took. Can't use function return value in right, blah blah blah, line 26. So what did I do wrong here? Row, another typo. So this took 0.0175 seconds. Okay, that's pretty fast, but let's see if we can make it even faster. So to compare our second method, I will unset the objects array, and then I will kind of collect the garbage with the garbage collector. Yeah, so let's start our timer even. So we're just selecting our first and only blog post, and then we select all the comments that are connected to this blog post. So instead of doing everything in one go, like we did here with the join, we are simply using two queries. So like before, we have objects of optimized objects, And for each comment as comment, we will say right, so we create, like before, post model for each comment, and we just enter the content from the first query and the comment as we loop through them. So let's see how long that took. Is micro time minus start, and we will have true, copy, and say multi-query method took this many seconds. So let's run this. So the first join method took 0.0276 seconds. The second one took only 0.0013 seconds. So you can see an order of magnitude. Let's try that again, and I will just add a new line character here so we can see better what's going on. So I'm going to run it again. Join method 0.02 seconds, multi-query method 0.001 seconds, so quite a significant improvement. So with a simple left join as your solution to the N+1 problem, you're not just downloading a blog post, you are downloading a lot of redundant data. But with the multi-query strategy, like in the second example where we have 2 queries instead of 1, we download the blog first and then the comments. These comments are all connected to the blog post, not by repeating the blog's body, but through a tiny memory reference. So what's the final verdict? Is the join a lie? Of course not. SQL joins are incredibly powerful for one-to-one relationships, or when you're only pulling small identifiers like IDs and slugs. But, as we've seen today, engineering is never about finding the perfect tool. It's about understanding the physical trade-offs of the tools you already have. If you blindly follow the advice to reduce the number of queries at all costs, you might accidentally trade a 2 millisecond network delay for a 200 megabyte memory explosion. By using the multi-query strategy for one-to-many relationships, you aren't being lazy, you are being surgical. You're leveraging how PHP handles memory references to keep your server lean, your network payload small, and your application scalable. Next time you're trying to solve your N+1 problem, don't just ask, how many queries am I running? Ask, how much redundant data am I moving? Thank you for watching my video. Please like, subscribe and share. Or, even better, buy me a coffee. Cheers for now.